The following is a videotape module from the learning system Seymour Papert on Logo. The tape series has two parts. The first, New Mindstorms, focuses on the process and the principles of learning. The second, Logo Hurdles, focuses on specific technical aspects of Logo. This is Hurdles tape number 2. Names and variables. Like the other Hurdles modules, it is intended for use with on-Logo study guides and computer diskettes.
Ever wonder why we chose those symbols, quotes and dots, for Logo? I'll tell you. Quotes are like two fingers. They're the two marks. Dots are like two eyes. On the side, all the same thing. Well, you might say, what's that got to do with it? What's that explain? I'll tell you. It's like this. Suppose you need some muffins, and suppose I want to oblige. There are three Logo-like things I could do. I could take one of these muffins I've just baked, and I would give it to you, see, on two fingers. Think of print, quote, cat. The quote marks take the word cat and give it to print. Print gets its input directly. Or I could do dots muffins. That's like telling you they're called muffins. You know, maybe you didn't know, maybe you speak some other language. And then it says, use your eyes. Because if you know what they're called and use your eyes, you'll go over and look at the jars, donuts, muffins, cookies. In the muffins jar, you'll find muffins. And then there's a third way. I would give you the recipe. That's like a procedure in Logo. Well, you'd break your own eggs. You'd beat it with milk. You'd put in flour, baking powder, melted butter. You'd put it in the oven. After a while, you'd have muffins. Well, I bet you don't believe me. Doesn't matter. This little story is an excellent metaphor for thinking how Logo works. And I'll leave you to contemplate it while you enjoy the muffins. Well, let's try and apply these muffin ideas in a more regular Logo situation. You'd be surprised at how much easier it makes learning Logo to have a consistent language for talking about and thinking about and teaching about Logo punctuation marks. I mean, these quotes, open list, close list, dots. I have a way of talking consistently. I say print, quote, square, and I say square is a quoted word. Print, list a square, and I say that a square, these two words are packaged in a list. I say print dot square or print thing of square, and I say square is dotted. And even in this case, where there's no explicit punctuation mark, it's quite important to have a name for it. I say that here square is unadorned. The advantage of having names for all four situations is that these are the four ways that a word can occur in Logo. Logo has 4 different and only 4 ways of treating a word, depending on which case you're in. Having this category helps you organize your ideas. In this tape, I'm going to concentrate on the dots, the dotted words. I'm going to assume that you at least know what happens when print, quote, square and print, list as square are run as instructions. I'd like to draw attention to just one aspect. You don't have to know any past history in order to know what will happen in this case. You can walk up to any Logo, doesn't matter what anyone's been doing to it, type this and you know it'll happen. Not so for this case. In this case, our work on output and reporters has shown us how to think about it. Print asks square for an input. The unadorned word is always treated as if it were a procedure. Print runs the procedure in the hope of getting an input, but its hope might be frustrated for a number of different reasons. First, there may not be any such procedure. If it wasn't defined, we'll get an error message, something like, I don't know how to square. Or perhaps there is such a procedure, but it's not a reporter, so it doesn't report anything to print. And we'll get another error message. So that in these cases, something must have happened before in order for these instructions to work. And what happened before makes a difference to how the instructions work. I'm going to focus on the kind of thing that happens in order to make this instruction work. I'm going to call it naming. Let's take an example here. Suppose I've said name to, quote, green. Name is a logo command. It's given a name to this logo thing, the number 2. That name is green. And when you've given this command, print dots green will print 2. Sometimes the instruction make, quote, green 2 is used in place of this. I really think quite a lot of confusion comes from that, especially with young children. I'm going to try to show you how this way of thinking about it is highly syntonic, rich in connections with everyday life situations. Whereas this one is very abstract, not connected to very much. Let's look at the same situation on a computer screen. Most versions of logo in the original form use numerals to obtain color effects. For example, in this version of logo, set background 2 will make the background green. Some people find it annoying to remember these numbers. A naming such as this one will give the color name green to the number 2, so that we can then give commands like set pen color dots green or set background dots green, and the turtle will change its color or the background or whatever without our having to use the numerals. The same idea can be extended to write a procedure, name colors, for example, which can be used at the beginning of the session to set up color names for all the numerals. I used 4 here, only not to clutter the screen. You would use as many as there are colors in your version of logo. Once you've done that, you can run the procedure name colors as a tool at the beginning of the session, and then use it to get effects such as this. You see here we didn't have to use numbers. We could say set background dots blue, dots green, and so on. By the way, I've known many children and even some teachers omit this step, as if they thought that defining the procedure would be sufficient to give these names to the appropriate numbers. Of course, you've got to run the procedure in the particular session in order for it to have its effect. It doesn't do anything just sitting there in the workspace without being run. In logo, naming is quite central. But this is because it's quite central in all thinking, in all communication, all teaching, and this has been captured in logo. The importance of naming in our lives is reflected in the ceremonial associated with it, the naming of a baby, the champagne bottle at the launching of a ship. In logo, the high priest of naming is the procedure name, and I'm going to be name actor for a while. I've brought these animals to help act out the way name works. Dog, I dub thee Fido. As name, I needed 2 inputs. This is my first input, a thing, and this is my second input, a name. In all naming situations, there are these 2 elements. This is the thing of this name, and this is the name of this thing. This is a language that's quite essential that you get into the habit of using. Let's use the cat to look at some other aspects of naming. I'm name. This is my first input, the thing of the naming situation. Its name, McCavity. Cat, I dub thee McCavity. Now, can it have another name? Can one thing have 2 names? Well, why not? Let's try. Cat, I dub thee Jelly Lorum. Is this a confusing situation in any way? I don't think so. we use names to refer to things. If I say jelly lorum, you know which thing I mean, this one. If I say macavity, you know which thing I mean, this one. And so in logo too, one object, one thing can have many names. For example, in logo there are no cats, no dogs, but there are numbers. And we saw how the number 2 could be called green. 2 I dub thee green. We could also give another name. 2 I dub thee duo. And if we did that, print dots green or print dots duo would make 2 appear on the screen. But what about 2 things having the same name? That's more confusing. Suppose that this lion were called Seymour. Somebody said Seymour. How would we know whether it meant this thing, me, or this thing, the lion? In real life, we deal with this confusion. In a class, if you have two boys called John, you invent an expedient for distinguishing between them. But in logo, in general, we don't allow it. When a name gives the name Seymour to this lion, it would take it away from me. That's what happens in general. In a later segment, we'll talk about local naming, which is rather analogous to the fact that if the lion and I were in different families, in different places altogether, no harm would be done by our having the same name. I'd like to get back to logo a little. As I said, we don't have cats and dogs, and as you know, what do we have? Numbers, of course. Numbers are special examples of what we call words in logo. And besides words, we have one other kind of thing, lists. And they too can be named. For example, this is, I'm being named now, my one input, a list. Here's my other input. It's a word which I can use as a name. List, I dub the animals. And now print dots animals will make this list appear on the screen. This is the thing and this is the name of a naming situation in logo, just like those we had with the animals. To use an idea, you must understand it, surely. But to understand an idea, you must just as surely use it. The art of learning is a spiral art. To find understandings that are limited enough to be accessible at the beginning, yet right enough to support real uses. From real uses, fuller understanding will grow. If you really understand logo, you'll know that in it, only logo things can be named. For example, you can't name a lion. But you can name the word lion, because words are logo things, and so are lists, but nothing else. Yet I'm going to take you on an exercise in which we'll deliberately restrict our understanding and talk as if we're naming something else. A position, a place on the screen. I'm going to use naming as a geometric technique for drawing this picture. Everything in it is very straightforward except for that triangle. How do you draw a triangle like that? Everybody knows how to draw equilateral triangles in logo when the 3 sides are all equal and the angles are equal to 120. But a triangle like that requires a different technique. Let's see how it works. Here's the turtle drawing the easy part of the church. Now there it sits waiting to draw the triangle. This is where you're going to use our geometric smartness. We name the place where it's sitting. Name, pos, that's where the turtle is, quote L base. And then we drive it over to the other side and name that R base for the right-hand side of the base of the triangle. We'll then drive it to the peak, of course in pen up mode, and we'll allow ourselves a little bit of fishing to find the right position. But when we have, we'll name that. Name, pos, peak. We've now named the 3 vertices of the triangle. The naming will pay off because if we now do pen down and then set pos dots R base, it will go back there, and set pos dots L base, and it'll go there, and finally set pos dots peak will send it to the point named peak. HT gets rid of the turtle, and we can clear our text away. And so you see how the report of pos can be used by somebody who does not yet understand that what it reports is a list of 2 numbers, the x-coordinate and the y-coordinate of a point. Perhaps even by somebody who doesn't even know that there are such things as coordinates. But the fuller understanding can come through use much sooner than you think. The next project shows a different aspect of the learning spiral. We're going to home in on a key moment in the evolution of a program. The programmer is about to encounter a fruitful bug.
Hi, Alex. What are you doing?
Oh, I'm making this new program. Here, I'll show you.
Hi, my name is Logo. What's yours?
Well, it doesn't know the difference, so I'll just put in Sandy Pit.
Sandy is a nice name. What kind of ice cream do you like?
Well, what kind of ice cream do you like?
I like chocolate.
Okay.
It says, my favorite is chocolate. Let's get both kinds. Some chocolate ice cream and some chocolate ice cream. It's kind of nice, but it's dumb, too.
Well, give me a break, will you? Come back in 15 minutes and I'm sure it'll be fixed.
Okay.
If you put yourself empathetically in Alex's position, you'll see something quite interesting about the evolution of thought processes. Alex knew that his program was going to choose chocolate, and this created a mindset in which he expected the user to say something else, anything, vanilla, strawberry, and had she done so, the program would not have seemed dumb. Her unexpected response opened a new project for Alex, a debugging project. He couldn't anticipate the obvious. No one can. Thinking works by a dialogue between the thinker and something outside, the objects you're thinking about. I'm going to reconstruct on the screen some key moments in the spiral process of debugging that carries Alex's program to the next stage of its evolution. In this visualization, I use color, blue, white, and pink, to represent 3 kinds of information. The blue originated with the program, the white originated with the user, the pink originated with the program under the influence of the user. What's in blue, the programmer knew in advance would be typed. What's in pink is typed in response to what the user typed in. Notice the origin of Alex's problem. Had the user said vanilla, we would have read, let's get both kinds, some vanilla ice cream and some chocolate ice cream, and all would have been well. As often happens with programming, the user chooses the one response that's going to give us trouble. Let's see how we can modify the program to get rid of this problem. The problem is in a sub-procedure to ice cream of Alex's program. Let's see how it was written. Alex noted that it had to begin by typing a message, a question, and then it was going to type something else, a message in 3 parts, a fixed text we saw in blue, and then in pink we saw what readList reported that the user had typed, and finally another fixed text. readList does make it responsive to what the user typed, but Lauren's giggles show that it was responsive in a kind of mechanical way, and we want to fix that. But before looking at the structure of this whole program, I'd like to get rid of some clutter. I note that the content of these texts doesn't really have anything to do with the structural problem that really interests us. So I'm going to show you a trick for cleaning up the layout so it'll look neater, give us more space to work in. I'm going to take each of these messages and give it a name so that we can refer to it by name instead of having the actual text there. I start with the first message. What kind of ice cream do you like? And I could give it any name I liked. I'll call it question. We do a naming. The thing is this message. What kind of ice cream do you like? And the name is question. Another naming. The next piece of text, and we could call it anything we like T2. I'm going to use a name, favorite, that's reminiscent for me of what the content is. And finally, we take the third part of text we saw in blue and give it a name chosen to recall what it says. Let's see how these namings help us tidy up the layout of this program. Notice print gets its input directly. I'm going to change that. It will get it indirectly as dots question. Neater. We can do the same down here. This print can get its third input as dots ice cream. Let's just move read list down and then do the same thing with its first input. Dots favorite. Clear that down to give us some space. We have a space there for the new part. What's that to be? It's sure to be a conditional, so write down if. You don't know what the inputs to if are. That's okay. Always put down what you do know for sure, then face the problems. Okay, take a guess. Read list equals list chocolate. Must be on the right lines because it's when the user typed chocolate that we got into trouble. What can we do in this case? A procedure, me too, could do something like say, wonderful, we have the same taste. But this leaves two bugs, and we can find them by running through the procedure in our heads on two hypotheses. First, on the assumption that user typed chocolate, and second, on the assumption that user typed strawberry. Chocolate first. At this point, read list would wait for the user to type something. We're supposing it's chocolate. It would be handed to equals as its first input. Equals would say true. Me too would be run. Well, that's what we wanted. But what happens afterwards? Ice cream had a plan. Its flow of control was this, then this, then this. And after me too, if would report, I'm done, and ice cream would go on to do this. So that after having said whatever me too makes it say, it would do the old stuff as well, which is obviously not what we wanted. How do we fix that? We need to put a controller in there. Stop. So that after doing me too, ice cream stops, doesn't do this. It's as if it came to end, and the program can get on with the job. Now let's see what happens if user types strawberry. We get false there. Okay, me too isn't run, doesn't stop. But when we get down to there, something unexpected happens. The computer will wait until the user types something. That wasn't our intention. We didn't mean two typings to happen. We didn't mean there to be two read lists. And I'm going to show you a trick for getting away with just one read list and using what it reports for multiple purposes. We do a naming. Name read list whatever you like. Flavor. Flavor would name chocolate or strawberry or vanilla or whatever. Now we take that read list, replace it by dots flavor. If the user typed chocolate, dots flavor is chocolate, and we would get true here. If it isn't chocolate, we'd want this one to be strawberry or whatever. We put dots flavor in there as well. There's the finished procedure. I'm skeptical about Alex's estimate of time. 15 minutes sounds like a typical programmer's underestimate. But this would not occasion or not deserve Lauren's comment, it might be neat, but it's dumb too. So there, that bug's out. It won't say the dumb thing, some chocolate ice cream and some chocolate ice cream. But is the program done? Do spirals ever end? In this segment, I plant the seed of an idea that we'll reap in Hurdle's Tape 4. I call the idea Names on Loan. The soil for this idea was prepared in the new Mindstorms tapes when we talked about giving procedures inputs. I also prepared a problem in segment 1 of this tape. Lion, you remember, wanted to be called Seymour, and I've conceded to the extent of calling the word lion Seymour. But suppose that Hedgehog said me too. Easy enough to dub Hedgehog Seymour, but then Lion would have lost the name. Maybe a dangerous situation for Hedgehog. Lion would be mad. Logo has ways of dealing with this situation. Of course, not for pandering to toy animals, but because losing your name is a serious matter. Logo gets a lot of its power from its ability to protect its logo things from losing their names. For example, suppose I wanted to run the procedure you've written. This simple one stands in for your complex and elegant creation. The only relevant point here is that you've chosen Seymour as the name for the input. When this procedure is run, the title line tells it that it needs an input and that it should name its input Seymour. In greet, quote, Hedgehog is the input. It's named Seymour, although there's no explicit name here, there's an implicit naming. Hedgehog is now the thing of Seymour, and that's why when greet runs, it will print hi Hedgehog. Hedgehog is the thing of Seymour. Will this get us into trouble with Lion? No, it won't. Because the naming that was done automatically here is only a loan. The name Seymour is loaned to the word Hedgehog. While greet was running, Hedgehog is called Seymour. But when greet reaches its end, the name is returned to its previous owner. Let's see how this works on a computer screen. Before putting lions, hedgehogs, and greet on the screen, I'm going to put the issue of giving and lending names in the context of a previous naming, one that we did as a tool so that we could change the color of the screen without remembering which numbers corresponded to which colors. But then suppose, after a while, seeking a name for this list, I chose green, forgetting about background colors. Then after another while, I forgot about that and did set BG dots green. But dots green now isn't a number 2, it's a list. I'll get an error. Set BG doesn't like a list as an input. Another example. Name, quote me, quote Seymour. Print dot Seymour, me. Name, quote lion, quote Seymour. Print dot Seymour, lion. What I want you to note is that this naming obliterates, without trace, this naming. If I was relying on preserving the effects of that in the computer, I'd have been badly damaged by doing this. Now, since I did both namings, I should take responsibility. But where I don't want to take responsibility is when I'm using your procedure. I don't want to have to know its technical details in order to use it. And as a matter of fact, when we look at its technical details, we might see there's reason for fear, because it uses the same name as I used to name lion. Name's Hedgehog, Seymour. But although greet does an automatic naming, it also automatically invokes a protective device, a loan system. It doesn't actually give the name Seymour to Hedgehog, it lends the name Seymour to Hedgehog. And the term of the loan is the duration of the run of the procedure. When the procedure is finished, when it gets to end, the name Seymour reverts to its previous owner so that the same instruction now produces another effect. This protective device, this loan system, means that I can use a procedure without having to fear that the way it names its inputs will interfere with any namings that I happen to have set up for any other purpose. I cannot overstate the importance or the richness of this idea of names on loan. Or maybe you understand it already pretty well. but you may still luck out. As you work with it, you may yet experience a few more times that intellectual high that comes when you find a new facet of understanding of a concept, for that matter of a person, you've known for a long time.